So in order to find the mean, standard deviation, min, max, and all three percentiles for the dorsal cranial length and the total length, I went to Stat, Edit, entered in all the data for each set. So in this particular example, I entered in the data for the total length, and then also went to Stat, Calc 1, enter, calculate, and it gives you all the data points required to answer this problem. And you do this for both the total length problems and the dorsal cranial length. Okay, for the histogram, all you do is literally select all 50 data points that we have been given. So for this specific example, I'm going to do total length again. You go to Insert, Chart, Histogram, and it brings up this, and you just go to Chart Design to add your chart title and your axis titles, and that's how you do the histogram. So the box and whisker plot is a little more complicated. First, you have to figure out all these values, which we did in question 1. So you can go ahead and do this, but you have to add specific functions for, the min and the median and max and so forth. But you just do that by actually typing in the function such as median, so median, and then all the data points. And then for the boxes, the box 1 is going to be the invisible box. So box 1 is going to be, just quartile 1. Box 2 is going to be the median minus quartile 1, and box 3, or the upper box, the yellow right here, is going to be the Q3 minus the median. In order to get the whiskers, you do the max, which is somewhere up here, minus quartile 3 for the top whisker, and for the bottom whisker, you do the Q1, which is right here, minus the minimum, which is right here, to get how far your error bars are going to go down. Once you have all this data, you can go to Insert, you can go to Add a Chart, and it's somewhere here. It's a stacked column chart. It's always hard to find. So you pick one of the stacked column charts, and it's going to give you, well, it's not going to bring it up right here, but it's going to give you something like this, but you're going to have to change the layout of it so it actually is capable of becoming a box and whisker plot. You're going to go to the stacked column options once you've selected it. You're going to go to switch row column, and it's going to turn it into this minus the whiskers. And in order to add the whiskers, you have to go to the actual chart, chart design, add chart element, error bars, more error bar options. Okay, it's going to take you to this. For the bottom whisker, you're going to go to a minus, because that signifies the bottom whisker. You're going to say add a cap, and you're going to go to custom, and you're going to specify a value. And for your negative value, you're going to put the value for the bottom whisker, and you're going to do the same thing for the top whisker. And that's how you do the box and whisker plot for both. For the scatter plot for question 3, all I did was I highlighted both sets of data all the way down to both 50 points. You keep it highlighted. You go to scatter plot, press scatter plot, and it brings this up. And if you want to add a title or axis titles, you just click on the chart, chart design, add chart element, and it gives you the option to add those as necessary. And because these two sets of points are so close together and they basically overlap, I'm saying that they are similar to each other, meaning they positively correlate. And if you vary the dorsal cranial length, the total length is also going to vary because the dorsal cranial length is within the total length of the actual animal that we're discussing. In order to determine the hypotheses A and B for question 4, we are going to add up all the points out of the 50. So there's 50 points for each one. So in this specific example, for DCL, you add, or you don't add, you count up all the points that are less than or equal to 260. And for this example, it was 22 out of the 50. So you do the probability of it being, or the dorsal cranial length being less than 260 mm. So 22 divided by 50 is 0.44. And you do the same thing for TL. So you count how many are 180 or less, and that equaled up being 23. So 23 divided by 50 is 0.46. And in order to find if both of them are occurring at the same time, you just multiply those two answers. So 0.44 times 0.46 is 0.2024. And these two hypotheses are dependent of one another because if you vary the dorsal cranial length, the total length is also going to vary. So the test utilized for these hypotheses will be one-sided because we're testing whether or not dorsal cranial length and total length are longer than a set integer. And I say that because the hypothesis is, or hypothesis A is dorsal cranial length is greater than 260 mm, and hypothesis B says that the total length is greater than 180 cms. So I stated my null hypothesis and my alternative hypothesis for both. And then I used the formula z equals x bar minus mu over sigma divided by the square root of n, or the mean. And I got those points, and the z-score for this was negative 1.914. And I utilized the z-table in the back of the textbook. So the p-value for the z-score of 1.914 is 0.028, meaning that the p-value is less than the specified alpha value, which is 0.05. So we reject the null hypothesis. While in total length, we used the same formula and got a z-score of negative 0.1963. Again, I utilized the z-table in the back of the book, and the p-value correlation to a z-score of 0.1963 would be 0.421 after rounding the z-score up to 0.2. So that p-value is greater than the alpha value, and when that happens, we fail to reject the null hypothesis.